Hey, hopefully you guys remember a lot of the substituting numbers in for variables because we're going to be doing a lot of that in this exercise. So this is exercise 5B, which is on circumference and perimeter of a sector on page 302 of your textbook. So let's just take a look at this diagram over here on the right. So looking at that diagram over there, we can actually see different parts of a circle. So this over here, that's what we call a radii, but that no one cares. Let's just focus on the different parts. So we've got over here is the angle, right? That's an angle. We'll just call it angle theta or theta. That's really up to you. So I just call it angle theta. So we've got a minor sector, minor being smaller. So a sector is that section there. And we've also got the major one. So for this exercise, we're typically going to be focusing on the angle part of this and then the sector part of it, okay? So given an angle theta, and I'm just reading this line over here, we can find the length of an arc. Oh yeah, this part over here is the arc. That's the arc. I should probably use a different color so you can see. There we go, that's the arc. So the arc is actually formed up of the outer ring of your sector. We can find the length of an arc using the rule for circumference of a circle. So just in case you don't remember, the circumference of a circle, is 2 pi r, okay? Or if you're using diameter, you can use pi d. I prefer using 2 pi r, it just makes more sense to me. So we'll be using this throughout this lesson. Once again, that's perfectly valid. Okay, so circumference equals to 2 pi r. When I say 2 pi r, it means 2 times pi, pi being 22/7 or 3.14 times by r. If you wanted to keep it in exact form, then you would just write pi. The reason being, and it's a bit of a counterintuitive topic to think about, is pi is a never-ending number. I think a lot of you guys know that's like 3.141 blah, 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 right? But if you write 3.14, you're actually approximating, you're rounding off the number, right? So instead of 3.1415, right? You've just cut off that and said, okay, it's actually just 3.14, right? That's approximating, that's not an exact value. So if you want an exact value, so if the question says, give me the exact value, you would just use pi. If you're approximating, for example, it's in a calculator, it just says put in this number, then you'll just use 3.14 or 22/7. They're both valid. Okay. Just in case you don't remember, a diameter is all the way from left to the right. So, for example, if this is the sun, then the diameter will be from the very left-hand side of the sun to the right-hand of the sun. Whereas the radius is you find the center and you go to any point. So it could be there to there, it could be there to there, whatever it is, right? So these are all radius, or radii, sorry, but let's just call it radius, right? The diameter is from here in a straight line all the way to the other side. So the formula we use is diameter equals to 2r, or the radius is half of the diameter. Makes sense. So what is the radius of a circle if the diameter is 5.6? Well, we divide it by 2, right? Because diameter equals to 2r. If I was to divide both sides by 2, I get d divided by 2 equals to r. But that's just the algebra way. We can just remember it as 5.6 divided by 2 gives me 2.8. So my radius is equal to 2.8 centimeters. Okay. So let's look back over here. I know there's a lot of words on the screen. A sector is a portion of a circle enclosed by 2 radii and an arc. So that radii is this side over here. So the 2 lines that form our radius. And our arc is this side over here. Okay. Special sectors include half circle, semicircle, blah, blah, blah. Okay. So let's not look at that. Let's look over here. So we're trying to find the perimeter, right? Perimeter is what we've been talking about for this and the last exercise. So if I look at this shape over here, it's a quarter of a whole shape. I can't draw perfect circles. I lied. Yes, I can. Okay. It's a quarter of a circle, right? Obviously, my drawing's not the best, but I'm going to fix it up so you can see. There we go. It's a quarter of the circle, assuming that's the center. If I was to split it up, you would see that, okay? Now, it's a quarter of a circle, so we're going to say that it's the fraction of the full circle is that it's a quarter, right? Or in other words, if I get rid of this, our understanding of angles, we know that that's a right angle because it's a quarter, right? So it's 90 out of a total, so that's the total, out of a total of 360 degrees, and that simplifies to a quarter. So there's different ways of doing that. So now I'm going to go ahead and say, well, the perimeter is actually equal to, now we're going using our formula of 2 pi r, so 2 times pi times r being 3. Oops. And I know r is 3 because that's this section over here, right? How's that? Yeah, it's a bit too small now. Okay, it's 3, so I can go ahead and substitute that value in. What else? Yep, and then I've got to add these lines over here, right? Because of the full circle, I've gone ahead and shown the arc, but I need to add the sectors. So I'm going to add 3, oops, sorry about that, and then add 3, or in other words, add 2 times 3, but we'll just leave it at that. And that gives us an answer of about 10.71. So that was a bit confusing, so let's go ahead and do that again. So for this one over here, we're trying to find the angle over there. So I know that there's a total of 360. I know that if I take away 90 degrees from that, I end up with 270 degrees. And if I simplify that fraction, I know that gives me 3 over 4. So the fraction of the full circle is 3 over 4. I can find the perimeter. Let's go ahead and do that. So let's add these lines first. So 4 plus 4 plus, now I need to find this arc over here. And so that's 3/4 times by, oh, I forgot to include a quarter earlier, my apologies. 3/4 times by, now we use our formula, 2 pi r, so 2 times pi times r, which is 4. And we would get our answer, which is, let's go ahead and put that in the calculator. So 8 plus 3/4, 1 moment, 3/4 times by 2 times by pi, and then times 4. And that gives us 26.85. Hopefully that's making a bit of sense. I'll do one more, and then we'll go ahead. I'm going to go ahead and try and get you to do this one by yourself, okay? So over here, I'm looking at this angle being 60 degrees, so I'm going to write 60 degrees out of a total of 360, right? I simplify that gives me 1 over 6, so the fraction is 1 over 6. The perimeter is equals to, now let's go ahead and do these lines first. So it's 6 plus 6, plus, now the fraction I'm doing is 1/4, so 1/6, my apologies, times by, and we use the formula, so 2 pi r, remember? So 2 times pi times r, my r is 6, remember this line over here is 6, so I get that. And if you put that in the calculator, 12 plus 1 over 3, 2 times pi, that gives me 18.28, alright? I want you to give this one a go. Pause the video now and then give it a go. Okay, I'm assuming you've paused the video and given it a go. Let's go ahead and do it. So that's a total of 180 degrees because it's a straight line. So 180 over 360, and that gives me a half. So we're looking for half, right? So my perimeter, once again, I go for the straight lines on the ends. So 5 plus half times, and then my formula, 2 pi r, times, times pi times r, my r is 5, and that gives me an answer of 5 pi plus 10, which is 25.71. Okay, this one's just a general formula to make you help you understand. So that's theta over 360, and then we'd say 2, so r, right? R plus r, or in other words, say 2r, it's the same thing, plus, now I go theta over 360 times by, now I use my formula, 2 pi and r. Okay, and that's actually what you find here. That's the formula we've got over there. So we've actually been able to derive a formula from our understanding. Okay, so that's the same formula, and that's the one you would use. Let's go ahead and put this into practice. So remember, that's the formula up there. I'm just going to keep it there. Now, instead of doing this step by step, I'm going to actually go ahead and straight up use the formula. So find the circumference of this circle and the perimeter of this sector. So the circumference of the circle, remember, is 2 pi r. So that one's quite easy. Now, I know that my r is 4, so I'm going to say C equals to 2 times r, 2 times pi, my apologies, times by 4, which is 8 pi. Yeah, and that's saying find it in 2 decimal places, so I need to put this in the calculator. So I'm going to put 8 times pi, which gives me an answer of 25.13. meters. Remember, be consistent with your units. Okay, let's go ahead and do this one. Using the formula that we've got over here, I'm going to say P equals to 2 times my R, which is 2 millimeters. So I'm going to write 2 plus my theta is 80 degrees. So I'm going to write 80 over 360 times by 2 times by pi times by R, which is 2. I put that in the calculator. I'm going to get 4 plus, 80 divided by 360, and then times 2 times pi times 2. Yeah, looks good to me. That gives me an answer of 6.79. And remember the units, so I end up with millimeters. Alright. Hopefully that makes sense. Do I have any other examples? Nope, that's it. Alright. Good luck. Let me know if you need any help.